Can you hear me now? For a very long time, humanity has looked up at the night sky and dreamed of visiting other worlds. Mars, the red planet, has always been a special neighbor, a place of wonder and possibility. We have sent robotic explorers there, little rovers that drive across its dusty surface, taking pictures and doing science. But talking to these robots has always been a slow process. Imagine trying to have a conversation where you have to wait minutes or even hours for a message to travel back and forth. This is the challenge NASA has been working on for decades, trying to find a better, faster way to communicate across the enormous distances of space. It's a fundamental problem for our future as space explorers. To solve this problem, some of the smartest minds at NASA came up with a brilliant idea. What if we used light itself? Instead of sending radio waves, which are like the signals your car radio picks up, we could send focused beams of laser light. Think about it. Lasers are incredibly precise and can carry a lot of information. This idea led to a project called the Deep Space Optical Communications Experiment, or DSOC for short. The goal was to build a system that could send messages using lasers from very, very far away to prove that this new technology could work for future missions to Mars and beyond. It's a science fiction dream becoming a scientific reality. The mission to test this amazing new technology was attached to a spacecraft called Psyche, which launched in October of 2023. As Psyche traveled deeper into space, the DSOC team on Earth prepared for a groundbreaking test. They needed to aim a laser beam from a telescope on Earth and have the spacecraft catch it, then send a signal back. This is like trying to hit a moving dime from miles away. On July 29, 2024, they did just that, sending a signal to the spacecraft when it was an incredible 290 million miles away. That's about the farthest Mars ever gets from Earth, proving that these cosmic phone calls are possible. This successful test was a huge moment for space exploration. It was not just an experiment, it was a demonstration of a new superpower for humanity. Imagine being able to send and receive information from Mars almost as easily as you stream a movie at home. This opens up a whole new world of possibilities. Astronauts could send high-definition video diaries back to their families, and scientists could get massive amounts of data from their instruments in near real time. This is the first step toward building an interplanetary internet, a network that connects worlds and allows us to explore our solar system in ways we have only dreamed of until now. So how does this laser communication actually work? And why is it so much better than the old radio wave systems we have been using for over 60 years? The best way to think about it is to compare a light bulb to a laser pointer. Radio waves spread out from an antenna like light from a light bulb, getting weaker and more diffuse the farther they travel. This means you need huge antennas and a lot of power to pick up the faint signal from deep space. A laser, however, is like a laser pointer. It sends light in a very tight, focused beam, which means the signal stays strong over much longer distances. Because the laser beam is so focused, it can pack in a lot more information. This is called bandwidth. Think of it like a highway. Radio waves are like a small country road where only a few cars can travel at a time. Laser communications, on the other hand, are like a massive, multi-lane superhighway where thousands of cars can zoom along at once. This means we can send much more data, much faster. While the best radio systems might struggle to send a simple picture, the laser system has been shown to send data at rates up to 100 times faster. This allows for things like high-definition video and complex three-dimensional maps of alien worlds. To show off just how powerful this new technology is, NASA decided to do something really fun. On December 11, 2023, when the Psyche spacecraft was about 19 million miles from Earth, the DSOC team used the laser system to beam the first ever ultra-high-definition video from deep space. And what was the subject of this historic video? A cat! An orange tabby cat named Taters, belonging to a NASA employee, was shown chasing a laser pointer. The 15-second video was sent flawlessly across millions of miles, demonstrating that the system could handle high-bandwidth content with ease. It was a playful and perfect way to mark a major technological leap. The success of the Taters video and the subsequent long-distance tests have been astounding. Even when the Psyche spacecraft was 240 million miles away, it was still able to send data back to Earth at a rate of 6.25 megabits per second. That is faster than many home internet connections. This capability will completely change how we conduct science in space. Instead of waiting hours or days for a few precious images from a Mars rover, scientists could receive a constant flow of high-resolution data. This would allow them to make decisions faster, explore more territory, and potentially make discoveries at a much quicker pace. It's a true game changer. While beaming lasers across the vacuum of space has been a spectacular success, bringing this technology down to the surface of a planet like Mars presents a whole new set of challenges. The biggest problem is the Martian atmosphere. Mars is famous for its massive dust storms, which can sometimes grow to cover the entire planet for weeks at a time. These tiny particles of dust floating in the air can block, scatter, or absorb a laser beam, making it impossible for the signal to get through. It's like trying to use a laser pointer in a very thick fog. The light just doesn't make it to its destination. To overcome this dusty obstacle, scientists and engineers are thinking about some very clever solutions. One of the most promising ideas is to create a hybrid communication system. This means we wouldn't rely only on lasers. Instead, future Mars missions would have both laser and radio communication systems. On clear days, they could use the super-fast laser to send huge amounts of data. But during a dust storm, they could switch to the more reliable, though slower radio waves to send essential messages and stay in touch. This gives us the best of both worlds, speed when we can get it, and reliability when we need it most. Another smart strategy involves carefully choosing where we place our communication equipment on Mars. By studying years of weather data from our orbiters, scientists can identify regions on the planet that historically have fewer and less intense dust storms. Placing our ground stations in these calmer, weather-safe zones would significantly increase the chances of having a clear line of sight for the laser beams. It's like building a lighthouse away from the foggiest parts of the coast. We could then use rovers to explore other regions and bring their data back to these communication hubs for transmission to Earth. Perhaps the most robust solution for the future is to build a network of satellites orbiting Mars. Instead of trying to beam a laser directly from the Martian surface all the way to Earth, a rover or an astronaut could send the signal a much shorter distance up to one of these relay satellites. The satellite, flying high above the dust storms and atmosphere, would then have a perfectly clear path to shoot the laser beam back to Earth. We could even have multiple satellites, creating a Martian GPS and internet service. This would create a truly dependable communications network, ensuring we can always phone home, no matter the weather on Mars. The success of the DSOC experiment is not just a single achievement, it's the beginning of a whole new era in space communication. This technology is the key that will unlock our ability to send humans to Mars and explore the solar system in person. When astronauts are living and working millions of miles from home, the ability to have a high-quality video call with their loved ones is incredibly important for their mental health and well-being. This laser technology makes that connection possible, shrinking the vastness of space and helping our explorers feel a little closer to home. It turns a distant outpost into a connected human presence. NASA is already planning the next steps. The upcoming Artemis II mission, which will send astronauts on a journey around the moon in early 2026, will be the first time humans test this technology in deep space. The crew will use an onboard optical system to transmit 4K high-definition video back to Earth. This will be a critical test to see how the system works with a human crew and will pave the way for it to become a standard feature on all future long-duration missions. It's one thing for a robot to send a signal, it's another for an astronaut to say, "Hello, Earth," over a crystal-clear laser link from lunar orbit. What's really exciting is how this technology could become more common and affordable. The system being tested on Artemis II is built almost entirely from commercial, off-the-shelf parts. This means that in the future, building a deep space laser communicator could be much cheaper and easier than it is today. This could allow not just NASA, but also private companies, universities, and other countries to participate more fully in the exploration of space. It democratizes deep space communication, allowing more people to join the conversation and contribute to our collective journey of discovery. It's science for everyone. Ultimately, this breakthrough changes our entire relationship with space. For generations, looking at planets through a telescope felt like looking at a postcard. a static, distant image. With laser communications, we are turning that postcard into a live, interactive video feed. We will be able to share in the discoveries and adventures of our explorers as they happen. We will see the canyons of Mars, the icy moons of Jupiter, and the rings of Saturn not as fuzzy pictures, but as vivid, detailed landscapes. This technology connects us all to the cosmos, making every person on Earth a passenger on the incredible journey into the final frontier.